Yeah, so I retired a little over a year ago. I was, as JB said, I was a wildlife biologist at the Refuge. And right about the time I was getting ready to retire, I think it was Rick or maybe Gordon kind of made a joke. We were talking about the need to analyze the forest bird data. And they said, well, Steve could do it in retirement. And I just kind of laughed. And then I got thinking about it more. And yes, this is data I've been involved with, and it's very important to get it analyzed. So I agreed to take it on, and with working with my partners here, Rachel Rounds from Fish and Wildlife Service Inventory and Monitoring, Rick Camp from USGS, and Ayesha Genz also from USGS and UH. Took some training on how to do these analyses about a year ago, thinking this was going to be a couple-month project. We're near the end now. We're getting there. What I'm going to be presenting here today is our first step is we're going to take these results, and we've taken these results and we've prepared a technical report that's going to be published by UH, and that should be coming in the next month or so. We're getting close to that. So what I'm presenting here are preliminary results. There's still one more step of review that it has to go through, but I don't expect there'll be a lot of changes. And then the next step is going to be the tech report is going to be mostly just reporting of results of the analyses, and the next step will be to prepare a manuscript for publication that kind of digs a little deeper into what the meaning of all these results. Just want to give some photo credits here. I didn't take any of these pictures that are in this slide. I stole them from wherever I could. A lot of them are Jack's, a lot are Raymond's, and also a lot just taken from U.S. Fish and Wildlife Service files. So, as most of you know, there's two units of the refuge. The Hakalau Forest Unit was created in 1985 to protect endangered forest birds and their habitat. It's about 33,000 acres. The Kona Forest Unit, some years later in 1997, was created with the same purpose, but also a focus on alala. It has grown in the last few years. It was originally about 5,000 acres. Now it's up to about 15,000, I guess 15,800 based on what Tom just said. So it's grown a little bit. Since the creation of the refuge, there's been several management actions implemented, building fences and removing the introduced ungulates. These actions are all taken for the benefit of the forest birds and their habitat. Removing invasive weeds, planting or restoring the habitat by just removing the ungulates. We had some passive restoration shown in those upper slides. And then also, as most of you are well aware, we've had a pretty active restoration program with planting native and endangered plants. There's some other things that we haven't taken so much action on that would benefit the forest birds. We do control predators, as was discussed earlier, but that's mostly focused on protecting the nene. There's not a lot of predator control at this point on predators that may be focusing on the forest birds. And then another thing that's we're monitoring, hasn't been a big impact yet, but rapid ohia death could be and have an impact on forest birds, especially if a lot of the ohia are impacted. So far, there's only been a few trees detected with rod over at the Kona unit, and I think there was just recently one at the Hakalau unit. And probably the biggest thing, this is a graphic that represents Hakalau here, but currently the mosquito line shown here in the yellow, currently it kind of bisects about halfway through Hakalau. As climate change occurs, that line could move up and we could get mosquitoes invading higher and higher into the refuge habitats, and that could have an impact on the forest birds. Right now, most of the birds are restricted to above 5,000, 4,500 feet because of this prevalence of disease at lower elevations. So what I'm going to be talking about here are the results of our annual surveys or semi-annual, depending on the site, that we do to keep track of forest bird populations. It's very similar to the methods used in the Hawaii forest bird surveys in the 70s and 80s. Variable circle point counts along established transects. This graphic here just shows some of the other sites that are being analyzed at some sort of interval. At Hakalau, the surveys have been going on since 1987 to present. We did miss a couple years in there, but 2020 because of the pandemic, and then 2009 was also missed. The surveys at Kona have been going on since 1995 at more irregular intervals. More recently, we were trying to do them annually, but there have been some years that have been missed in there as well. Previously, these data had been analyzed for Hakalau up through 2012 and for Kona up through 2002. So there was quite a gap where the data had not been analyzed. So that's why the importance of taking this project on. Just to show the study sites here, Kona or Hakalau on the left, there's 14 transects there, but we recently been doing a subset of those, 10 transects that we surveyed with 260 survey stations on those transects. And at Kona Forest Unit, we have 4 transects. We only survey Kona, the original Kona unit is fenced into 3 management units. We only survey the upper 2. The bottom one is low elevation, heavily invaded with non-native plants. So we really focused on the upper area where we expected most of the birds to occur. And there's about 146 survey stations at Kona that we've included in this analysis. We focused on 10 species, 6 honey creeper species. You're probably familiar with most of these. The Hawaii creeper, I'm going to be calling Alabi. It has a new official Hawaiian name. I think it's official. We also looked at 2 non-honey creeper species, the Hawaii Alopaio and the Ma'o, and 2 non-native species, red-billed leothrix and Japanese white-eye, now called warbling white-eye. I'm not going to present a lot of results, or I'm not going to present results for leothrix and white-eye in this presentation, but they will be in the technical report. I have quite a bit to go over here, so just to keep things a little bit shorter, I cut out the non-native species. So the 2 study areas at Hakalau Forest, we divided the study area into 3 strata. The highest elevation, so at Hakalau, the strata are based on habitat. But the highest elevation is the pasture, what we call the pasture. This is the area where the koa plantings have taken place, was former grassland. Then the largest area is this open forest area, the brown here. And then that goes down to fairly low elevation in Malua and below Malua. And then the lowest elevation is the closed forest area. This area was not impacted as much by grazing and cattle activity. Whoops, sorry, let me go back to Kona. Kona, we divided the upper area into 2 strata, the upper and lower, along the 1524 meter elevation line. That comes out to 5,000 feet. That's about the elevation we thought mosquitoes would be having, and it could be having an impact. So just a little bit more on the different strata. The open forest, like I said, is the largest, 7,900 acres. It does go down fairly low elevation, but the majority, the average elevation of this area would be higher than the next strata, the closed forest. And it's mostly ohia and koa ohia mixed. The closed forest is about 5,000 acres. Shoot, I look like I got a mistake in my calculations here. It's 1,998 hectares. So that should be smaller than, oh wait, no, I got it right. Okay, never mind. And then and that goes from about 1,400 meters to about 1,700 meters. And then the pasture or the afforested area is about 3,200 acres, highest elevation. This is the area that's been planted with koa and understory plants. Many of you have helped out with that over the years. Koa planting started there 30 or more years ago, shortly after the refuge was created. So that area does have a canopy of forest with some native understory plants, but a lot of native grass too. So the whole study area that we included for Hakalau is about 16,000 acres. At Kona, we divided, as I said, into 2 areas. An upper area, about 1,700 acres. This tends to be more dry, subalpine ohia and mesic koa ohia. The lower area is a little bit larger. It's wetter. It's wet mesic ohia with some koa mixed in. You can see Kona is about 1/4 the size of the area that was included for Hakalau. You guys seen this pictures a couple times already of Dick doing a survey. I couldn't find anything more recent of anybody doing a survey, at least at Hakalau. But we do, in the bottom right here is showing, we do use trained and experienced bird counters. We do a day of training where we go over the methods and bird identifications. We have some very detailed protocols that we follow. We survey from dawn to around 11 o'clock, and we have some limitations for weather when we would stop surveying. Just to go over distance sampling a little bit. So we have the observer goes to a station, does an 8-minute count, recording everything they hear and see in those 8 minutes, and the distance to that bird, estimated distance to within a meter. Hopefully we're highly accurate. That's why we do some training and practice. Some of us use rangefinders when we're out there trying to get as accurate as we can. So the density of birds, the number of birds detected close in the area is relatively small, so there'd be fewer birds, and the farther out you go, the more birds that would be detected. But there comes a point where you're missing birds. You're not detecting birds when you get farther away, so that the number of birds actually start dropping off. And what program distance does is comes up with a detection probability of detecting a bird based on the distance. And using these models, we can come up with a population estimate. Some of the covariates we included in our analyses are clouds and rains, wind, observers. There's a large number of observers over the years, the 30 plus years that this has gone on. Type of detection, time of detection, and the year. So just copied a couple pages out of a survey book here, just so it shows you some of the data we collect. And then actually here's an actual copy of a page from a data book with some of that. So the interesting thing to note here, besides all the covariate information we collect, we do collect stuff on ohia phenology and some habitat stuff here. That's a little complicated. I'm not going to go into it, and we didn't include it in our analyses. But for every bird, we listed detection type. Was it heard? Was it seen? Was it heard first and then seen, basically? And then a distance to the bird in meters. And not rounding off, we get it as close as we can to the actual distance that the bird was from us. That's an important requirement. So from program distance, then we come up with population estimates for the birds, and we have an estimate for each year that was surveyed. I'm only showing the most recent estimate for 2019 here. There have been surveys done since then in 2020, but they weren't included in this analysis. So a couple interesting things to note here. At Hakalau, the most abundant species the last year, and this pattern was consistent throughout most of the years. EEV were the most abundant, followed by Apapani, and then similar to Apapani were Amakihi, and also a fair number of warbling white-eyes. At Kona, this is really interesting that the Apapani numbers are quite high, 109,000. Again, considering that this is a quarter the size of the Hakalau survey area, that's quite a density of Apapani. And actually, it comes out to over 7,000 birds per square kilometer, which is previously been reported 3,200 Apapani per square kilometer in the volcano area. This is considerably higher than that. So we have some of the highest recorded densities of Apapani at the Kona unit of the Refuge. And any of you that have been there to do a survey, I made a joke years ago. It's a headache of Apapanis when you're trying to count them over there. There's a lot of Apapanis, but also Amakis fairly abundant. EEV much less abundant over there. And then yeah, white eyes too are fairly abundant. Okay, yeah, I kind of went over this already, but the difference, interesting difference between the two units where EEV are the most abundant at Hakalau and Apapani are the most abundant at the Kona unit, and EEV are fairly low numbers comparatively at the Kona unit. So the next step in our analyses then is we have these population estimates from distance, and they're shown here in the black dots with error bars here. And then we plug this data into some state space models. And what happens there is And this is an example here of the Kiapola'au in the open forest strata. What happens in state-space models is you smooth out some of these unrealistic estimates. Like for example, here, there was a very low estimate of Kiapola'au in this like 1993, and 1994 is quite high. And biologically, that's not possible for that much of a change in the population. So the state space smooths that out a little bit here. We have the blue dots are the estimates from the state space models. And then the blue line is the trend connecting those blue dots. And then the gray ribbon is the error around that trend. And if you want more explanations on state space models, Rick Camp is on here and he can talk about it afterwards. Okay, so this is what we've all been waiting for, some of the results. So at Hakalau Forest, we did 2 analyses. We looked at the entire survey period, and then we looked at the most recent decade. So the entire survey period for the open forest and the pasture goes from 1987 to 2019. For the closed forest, it goes from 1999. Those lower stations were not added until 1999. And because of the total strata is all 3 of these strata combined, that also goes from 1999 to present. And we classify the trends as either upward, stable, downward, inconclusive. That's a result of a lot of variability, so it's inconclusive, and then insufficient data. And you'll see in the next graphs, I use double arrows for trends where there's strong evidence or very strong evidence. The probability is over 0.7 of those trends. So I'm going to break it down by strata and then by survey period. So the open forest, again, this largest area, the area that was had canopy but had been grazed underneath, that's come back. If you look at the entire survey period, most species, several species have stable trends. A double arrow means that there's high evidence, or strong evidence that these trends were stable. Apapani has a strong evidence of an increasing trend. A couple of the endangered species, the Kiapola'au and Alabi, have weak evidence of a stable trend, and Akepa has weak evidence of a downward trend. If we look at the closed forest, this lower elevation area here, over the entire study period, you can see most of the species are showing a strong evidence of a downward trend. The exception is Apapani have strong evidence of a stable population, and Akepa is inconclusive. There's a considerable amount of variability there. The pasture, this restored area, is kind of as you would expect, as it's gone from grassland to koa forest in the 30-plus year time period of this survey. Most species, most species are showing an upward trend. Everything is, except for Akepa, we didn't have enough detections. Akepa depend on old growth ohia. Akepa really have not moved into this area, so we didn't have enough detections to analyze their populations. Now going into the most recent survey period, it's from the most recent decade, from 1999 to 2019. In the open strata, you can see that Apapani, they have moved from a downward trend to an upward trend. Let me make sure I got that right. I'm sorry, I had that backwards. They moved from an upward, well, sorry, I got something messed up here. Okay, but Apapani have a strong upward trend. Eevee are showing a strong, stable trend. A couple other species have a weak evidence of a stable trend, the Elapaio and the Ma'o. And then a couple of the endangered species in the open forest are starting to show evidence of a weak downward trend. And then a couple, there was enough variability that the trends were inconclusive. In the closed forest, oh wait, oh I'm sorry, that's where I got messed up. Sorry. I got on the wrong slide. that was the overall population. Now we're going into the most recent decade. So so here in the open forest, there's still several species that are showing stable populations, but weaker trends. You remember these were stronger trends when we looked at the entire survey, stronger evidence of the trends when we looked at the entire survey period. Apapani and the two endangered Alabi and Akepa have moved to a strong evidence of a downward trend, and Akiapola'au, the results were inconclusive. In the closed forest, almost everything is now in the most recent decade is showing a downward trend, except Oma'o. They have strong evidence of an upward trend. Several other species have strong evidence of downward trends, and Akiapola'au also some weak evidence of a downward trend. In the past year, you remember from previously over the entire survey period, pretty much everything had a strong evidence of an upward trend, and still several species still do. But there's a couple interesting changes here in this past year. The Akiapola'au and the Apapani now are showing strong evidence of a downward trend in the pasture strata. And then EEV previously had strong evidence of an upward trend. Now there's been enough variability that in the pasture area that the trend is inconclusive. So overall, for all the strata combined in the last decade, Oma'o showing strong evidence of an upward trend, Akiapola'au weak evidence of an upward trend, Akepa and Apapani strong evidence of a downward trend, and Alabi weak evidence of a downward trend, and then 3 species inconclusive because different things were going on in different strata. So now I'm going to move into the Kona. I'm going to do this a little bit different. There was fewer strata and fewer species in only one time period from 1999 to the present. But first, just look at the strata for the 4 native species and the upper higher elevation area. Interestingly, this is the Elepaio. This is the area we thought would be less impacted by mosquitoes, and Elepaio are going down. There's a downward trend in their population there. Amakihi have a stable trend. The Ibi have a weak evidence of a downward trend, and Apapani have strong evidence of an upward trend. And opposite of what we expected, there's a couple species in the lower area that are showing upward trends. Weak evidence of a stable trend for Amakihi, and EEV were inconclusive. So overall, kind of a mixed bag with weak evidence of stable populations and decreasing populations for EEV, strong evidence increasing for Apapani, and inconclusive for Elepaio. So just going to look at this species by species real quickly here too. So Elepaio doing 2 different things, decreasing in the upper, increasing in the lower. Amakihi stable in basically the 2 strata. Weak evidence overall that their population is stable. Weak evidence that EEV are declining, but Apapani continue to show strong evidence of increase at the Kona unit. Okay, this slide's got a lot of information on it. I'm going to kind of key on a few things here. So what we did here is we looked at the most recent estimate for the 2 units and then combined them to come up with a total estimate, and then compared that to the global estimate or the statewide estimate. So for most of these species, the total estimate is from Gorison et al. 2009. So these are a bit outdated. We do have some updated estimates for EEV and Akepa. EEV from 2003 from Evan Paxson et al. And Akepa from Seth Judge et al. In 2018. The interesting thing to note here, again, even though these numbers are somewhat dated for the global or statewide populations, the refuge still supports a high percentage of the populations for the 3 endangered birds here, for Alabi, Akiapola'au, and Akepa. And even the threatened species, the EEV, the refuge still supports probably 20% of the global population and 22% of the statewide population. So I'm going to just quickly go into some conclusions that we have here. That about half the species continue to show upward or stable trends at both refuge units. Recently, several populations at lower elevations in all strata at the Hakalau Forest Unit have downward trends. Most species continue to show upward trends in the reforested pasture stratum, although this trend is recently reversed for some species. This pasture strata supports a relatively small proportion of the population overall, but it's likely to become more important as it regenerates and matures and the mosquito line and disease moves up. The Kona forest was more mixed. Some species were showing downward trends in the upper strata and upward trends in the lower stratum. There are very few endangered birds detected at the Kona Forest Unit. I didn't mention this earlier, but you saw that we did not have population estimates for Akea pola'au, alavi, or a kepa at the Kona Forest Unit. A kepa had not been, Akea pola'au, sorry, had not been detected for several decades at the Kona Forest Unit. We did have a few detections of alavi and a kepa, but not enough to actually estimate populations. And also a non-endangered species, but oma'o, have not been present on the Kona side of the island for several decades. So they're not present at the Kona Forest Unit. And then the threatened species at Kona, iiwi, are showing evidence of a declining population. So management actions thus far have led to some positive trends, but there may be additional stressors that are starting to show some negative influences. And a final point I'd like to hit on again is that the refuge does remain one of the most important or more important areas for forest bird conservation in the state of Hawaii. As I said, we're gonna, the next step is to dig into this a little bit deeper in a manuscript. And I'm just gonna throw out some ideas here that we'll explore further, and this will likely change as the manuscript is developed, but just a few things to think about and probably some questions that you guys have in your heads right now. So maybe we can look at what trends how have the trends changed since the previous analyses. Remember at Hakalau, last time data was analyzed was through 2012, and at Kona it was through 2001. Are birds shifting upward at the Hakalau Forest in response to habitat management or disease pressure? How do the trends that we're seeing at the refuge compare to other sites on Hawaii Island and in the state of Hawaii? What's going on with the iiwi and apapani at the two units? Iiwi, as you know, are fairly aggressive. Maybe they're suppressing the population of apapani or vice versa without iiwi at the very high populations of iiwi at the Kona unit. That's allowing the apapani populations to increase. Has the pasture strata reached carrying capacity for some species? As I noted, there's a couple species in the last decade that are showing evidence of decline. There's been some research done at the refuge where even though we have a koa canopy and some understory species that have been outplanted, it's really kind of slow at becoming a full functional forest ecosystem. So maybe with the kikuyu grass is inhibiting the restoration of some of the understory species. What's going on at the lower elevations of Kona Forest? Interestingly, as I mentioned, several species are showing increasing populations there, or upward trends. But Alopaio are doing the opposite of what was expected. They're declining in the upper elevations, increasing in the lower elevations, and they seem to be declining in higher elevations elsewhere in Hawaii as well. Could climate change driven shifts in phenology impact the surveys? We do them at the same time every year for the last 30 years. Maybe something is happening that could be impacting our detection of birds at that time of year. And finally, what management actions could be implemented to better benefit the birds? I just want to give some acknowledgements here to the many trained observers who helped collect the data over the years. Jeffrey, who led and organized many of these surveys. Kevin Brink with USGS provided training and the scripts that we use, and then funding from US Fish and Wildlife Service, UH Hilo, and USGS. And with that, if we have time, I'll leave it open to questions.